Hey guys, in the last video we went over 3 practice problems regarding number theory on the ACT. In this video we're going to go over the actual concepts and make sure our knowledge base is solid. Now before we go into this, let's just talk about whether or not this video will be useful for you. So let's go into some of the statistics. How often will you be asked questions about this information? I realize I wrote statistics. Okay, so I would say just on personal experience that you might get 2 questions on average about this information. So I would say this video is perfect for somebody who has a pretty high score, 28 and above. If you already have that kind of score and you're really reaching to get, like a 30, or if you're at a 30 and you're trying to get 32, this is a really great video to make sure that you have a complete comprehensive knowledge base. Okay, so I'm going to jump right into the definitions here, and I'm going to work my way up this way. I'll start at natural numbers and go up and over. So natural numbers are and maybe you could even predict what they are, because you could ask yourself, what are the most natural numbers in the world? 1, 2, 3. Well, those aren't naturally good-looking numbers. Can't draw. But 1, 2, 3, 4, 5, on to forever. Is a negative number natural? Not really, right? A negative is pretty abstract. It's like you can't count negative apples at the Apple store. So natural numbers are positive, and they're whole numbers. They're positive whole numbers. Integers are whole numbers, but they can be negative as well. So 1, 2, 3, and onward, but also -1, -2, -3, and onward. One good way of remembering integers is that they share the same kind of the root word integ. They're the same root for integrity. So integrity, if you know someone who has a lot of integrity, they're very rock solid with their word. This you can associate them with integers. They can be negative or positive, but whole numbers. They're whole. They're counting numbers. You can think of them that way. All right, the next one up on our list is, I'm going to go right here, fractions. I'm going to go to the fractions. Integers are a subset of rational numbers. So rational numbers can be expressed by a ratio. That's part of their name as well. So 1/2 is a ratio of 1 to 2. It's also a fraction. Fractions and ratios are, synonymous basically. Here's some more rational numbers. Pretty standard stuff. They can be negative as well, right? -1/4 is another example of a rational number. One quick interesting thing, 4/1 is another way of saying 4, and 4, as we know, is an integer, right? It's also a natural number. So take a look at our chart and see that integers are a part of rational numbers. So that's kind of what we mean. Except for rational numbers also include fractions. So if we go back to this, we see that rational numbers include fractions, but they also include integers. Okay, next thing up is irrational numbers. The prefix ir, means not. So this means not rational, or cannot be expressed as a ratio. The classic example of an irrational number is root 2. So another example is root 3, and root 5, root 6, and root 7, and so on. And I'll say also pi right now. Pi is another irrational number. I skipped over root 4 because root 4 you can simplify into 2. And if you notice 2, it is an integer, it's a natural number, it's also a rational number. You can write it as 2/1. a good rule of thumb is that there are square roots, but they do have exceptions. The exception is perfect squares. So root 4 is not irrational. So is root 9 and root 25 and root 36 and so on, right? Root 49. Okay, so I'm going to go to the next thing, which is imaginary numbers. Now I'm going to do a whole other video on imaginary numbers, but for this video I will say that they are typically represented by I, which is equal to the square root of -1. The reason why they're imaginary is because this is not something that can happen in real life. You can't take the square root of a negative. However, for some mathematical purposes, it's really nice to imagine a world, or just use our imagination and be like, well, what if we had square root of -1? What if we could do that? And there's a whole field of math, and so much of mathematics is built around this, but we're just taking the ACT, so I'm not going to go any deeper into it here, and I'm going to do another video explaining what you need to know about I on the ACT. Now, lastly, we're going to go over complex numbers, right? We've covered we're going to go over real numbers, and then we're going to go over complex. So I'll actually stay on this page because look, real numbers include rational numbers like 1/3. They include irrational numbers like square root of 2 or pi, and they include fractions. They include integers, whole numbers like 1, 2, and 3, and they include natural numbers like 1, 2, and 3. Now, real numbers sometimes expressed like that, but you don't need to know that on the test. Real numbers are basically everything, right? There's not much else that you can there's not much else. Like, real numbers, basically, if they ask you for a real number, you could think of it as anything on the number line. So you have 0, you have 1, you have -1, you have the square root of 2. That's on the number line. You also have 1/2. That's on the number line. And you also have, is that everything? Yeah, that is everything. So anything on the number line is a real number. Okay, complex. Complex means a combination of real and imaginary. And typically speaking, is written in this format, which we will not go deeply into today. But this is a real number, this is a real number, and I, as we know, is imaginary. We just need to know that a complex number has real numbers combined with imaginary. It's a combo of imaginary and real. Okay, with that said, I am going to jump into the practice problem that we have for today. For every pair of natural numbers, n and m, to which of the following sets must n plus m belong? So you have natural numbers. What are natural numbers? Things like 1, 2, 3. And we are going to add them together. So I'm going to take 1 and 2. This is going to be my n. This will be my m. I'm going to add them together and I get 3, right? So 3 is is 3 a natural number? Hey, look, 2 r's. My bad. Is 3 a natural number? Yes, it is. So is 3 an integer? Yes, it's a whole number. Yeah. Is it a rational number? Yeah, we can express 3 as 3 over 1. So yes. Is it a real number? Real numbers, remember, are like pretty much everything you can think of. So yeah, it is. But let's see, V, the complex numbers. Is 3 a complex number? Now this is where I guarantee you, like, most people will get it wrong. 3 actually is part of the complex numbers. You can look it up online, but here's my explanation. Remember that A plus BI format. You can write 3 as 3 plus 0i. Now, anything times 0 is 0. So this cancels out and you're left with just 3. And does that seem a little bit like maybe unfair and biased towards people who are really mathematically advanced in high school? Absolutely. However, that's what you have to know. So if you want to look up more information about it, go to Khan Academy or something like that, or go to your teacher, and they can tell you more about like standard format. They can give you practice problems to work on it. But again, just manage your time as well. This is one question. This was just one question out of literally hundreds that I've done.